Natural variability, or the nature of natural variability. Today's our third point on this, and here we look at visualizing to check our interpretations. We can compare what our ANOVA says about variables that impact variability to what our visualizations show. The visualizations and ANOVA should be telling you the same thing. So we can use these visualizations to check our interpretation of the ANOVA. We're going to use the example from what is in an ANOVA table guide given in topic 9. Let's just briefly recap on this data though. This was data that was used, it gave the yield of 58 varieties of soybeans. It was experimental data, which meant that there were different variables in there to compare to. It was soybeans grown across 4 locations in 2 consecutive years in Australia. So the 2 years were 1970 and 1971, and then there's 4 locations. There's 464 observations or rows, and so some of the variables in this example are yield, oil, protein, year, environment, genotype, and so forth. So what we're going to do is we're going to really dig in here. And so let's look at oil first, and let's look at what does this mean for an oil in an ANOVA versus a visualization of oil against yield. So we can see from a table here that we fitted oil in our ANOVA, and this gives 1 degree of freedom, which makes sense because it's a numeric variable, and the F value is 185.74, which is much greater than 1, implying that oil accounts for a large amount of variability in yield. This completely aligns with what we see when we plot oil against yield. So when we have a continuous variable in an ANOVA, we're essentially fitting a line to the data and checking if it's horizontal. That means that there would be no effect. If we had a horizontal, we do not have a horizontal line here. We have a line that's showing an increase. So we can see that the line of best fit is not flat or horizontal. There's therefore a relationship between yield and oil. As oil increases, so does the yield. Here, this is great. The ANOVA fits the interpretation. The ANOVA shows that oil accounts for some variability in yield, and the plot agrees. Now we'll take an example using a factor. So let's add a year to our ANOVA. Here, we again have 1 degree of freedom in our ANOVA table because there's 2 years. And our number of degrees of freedom will be the number of factor levels minus 1. And the F value is, again, pretty high at 145.91. This implies that year does impact the yield, that year does account for variability in the yield. When we have a factor variable in an ANOVA, we're basically checking if the yield in the different factor levels are equal. So we can look at year to see if it accounts for variability in the yield. And we can see here through our plot that we can see here through both our plot and our ANOVA that year accounts for some variability in the yield. The 2 box plots are not identical. And so our ANOVA fits the interpretation. The ANOVA and the plot show that yield accounts for some variability. Sorry, that year accounts for some variability in the yield. And now we're going to look at protein. So again, we've got another continuous variable. So again, our degrees of freedom is going to be 1 because it's a numerical variable. And again, we can look at a plot. And our plot shows that there is a fairly good evidence, pretty convincing stuff there, that protein does impact the yield, that higher protein values result in a smaller yield. However, when we saw this with oil, we had a huge F value for oil. We come back here, we saw a very similar trend, just instead of decreasing, it was increasing with oil. And our F value is over 100. When we add protein in, our F value is 1.19. This is incredibly interesting. So protein does not seem to impact yield from the ANOVA, but from the plot, it does look like it impacts yield. So what's going on here? Our interpretation of the ANOVA does not align with what we're visualizing. Well, our ANOVA suggests that protein does not account for variability in the outcome, but our plot suggests otherwise. Therefore, this implies that protein is correlated to another variable which is placed in the ANOVA before protein. In other words, protein is placed in the ANOVA after oil and year, so protein is strongly correlated with either oil or with year. The variability that protein accounts for has already been accounted for by another variable correlated with protein. And to also add to that, well, this image on the right is technically not the correct image of what the ANOVA is doing here, because we've got oil and year also in there. So we're just going to look at it with one at a time for the variables, just to avoid too much complexity. But let's look at protein and oil together against yield. Well, we can plot this. So we've got our protein on the x-axis, our yield on the y-axis, just as we had before. And now we've put oil to be to color our points by oil. And we see that those lower values of oil correspond to a lower yield. And those higher values of oil correspond to a higher yield. And we can see here that as our plot goes from left to right, our values become more red because there is a correlation here between oil and protein. There's higher yields from higher oil values, there's higher yields from lower protein values. Oil and protein seem to be correlated. Oil is in the ANOVA before protein, and it accounts for the variability that protein would have accounted for. This is why protein does not account for much variability in our outcome according to our ANOVA, but it does account for much variability in the outcome according to the plot when we looked at just protein by yield. And still here as well, it looks like, well, protein accounts for a lot of variability. We can see it in our plot here. What do we do then? Oil and protein seem to be correlated. What do we do? We should look at the fact that oil and protein are correlated to one another. Our data is not an experiment on oil against protein. Therefore, there's no evidence to know which of oil or protein is causing the changes in the yield. Because they're correlated to one another, their ability can be accounted for by one or the other. So just to illustrate, in our top ANOVA here, in our first one here, we have that if we fit protein after oil and year, then protein does not account for much variability in the yield, since oil has already kind of taken up the variability that protein accounts for. But if we switch that, if we put protein in before we put oil in, now our F value for protein is much higher, much, much higher. We can see protein does account for variability in the yield because oil's not yet taken up that variability that protein accounts for. So all this means here is that basically the order we put it in has changed the how much protein accounts for, because protein and oil are so strongly correlated. Both oil and protein account for variability in yield. Using visualizations to check your interpretation is good. The visualizations are helping you to interpret your protein results and reach the correct conclusion. Here, the correct conclusion is that protein and oil account for the same variability, rather than that protein doesn't account for any variability. If we go back a few slides, when we first were introduced to protein in our ANOVA, we could have fallen into a trap here by assuming that protein doesn't account for any variability in yield. But if we then looked at our data, we see that it does. And the reason why the ANOVA showed that it doesn't is only because of this relationship it has with oil. In this situation, you can talk to experts or see otherwise on, okay, well, do we use oil or protein? But at the end of the day, it's about that interpretation. The correct conclusion I know that I've said this, but I want to really reiterate it. The correct conclusion is that protein and oil account for the same variability, more or less, rather than that protein doesn't account for any variability. So, I mean, we've looked at protein and oil and we've seen some correlation there. We should really look at year and protein together too, because year can also be correlated with protein. In addition, we actually technically should here be visualizing, because our ANOVA is at this stage looking at oil, protein, and year against yield. We should actually be visualizing all three together. But we're not here, because in our example, we can explain these discrepancies between the ANOVA and the plots by looking at just two variables at a time, which is a lot simpler to be able to discuss this point. But let's just briefly look at protein and year. So we should check if year also accounts for variability in protein, and we can do this by an ANOVA. If we remove year in the ANOVA, we can see how much variability protein now accounts for. When year is not in the ANOVA, protein accounts for more variability in the outcome than when year is in the ANOVA. What we mean by this is if we look at this top ANOVA here, our protein F value is 1.19 when we have year in, and when we remove year, our protein value is up to 5.88. Our protein F value is up to 5.88. Hence, year is accounting for some of the variability in the protein variable. So let's just dig into this one very briefly. And this is really important that we dig into protein in year, because this is in case year is a proxy variable for protein. A proxy variable is a variable which accounts for the variability that another variable should account for. This could be really dangerous for something like year. Year has shown a difference in yield. However, it's not that one year is magically better than another. It's actually due to another reason why one year results in a higher yield. For example, protein. It might be that for a particular year, we had particular protein levels. It could be for 1970, we had really high protein levels. And then because of those high protein levels, that meant that we had a much lower yield that year. So it is important to check these things. If year were a proxy variable for protein, we may want to use protein in our ANOVA instead of year to account for variability, since protein explains that year effect. This can also be found with things like village, region, those sort of variables which aren't causal. A certain village is not going to be your reason why you've got a different yield. It might be to do with an aspect of that village, the rainfall amount in that area, the soil type, and so forth, the type of land. So if we plot yield against protein, and we're going to color by year here, we can see that the yield is higher for 1971 than for 1970, regardless of the protein variable. So if you look at kind of protein around 40, it's year is higher there, regardless of what our protein value is. Now, if we saw that most of our 1971 values were for a higher protein, so if we saw that most of like this right-hand side of our plot was in orange, and these all happen to be a lower yield, well then year may be a proxy variable for protein. But this is not the case here. It does not look like year is a proxy variable for protein. We should look at other variables to see if year is a proxy for them, but we won't in these slides. So I just wanted to say some final thoughts on year before moving on. Because year is always a very interesting variable. Year may be treated as a factor or may be treated as a continuous variable, depending on the question you wish to ask. So in our top plot here, we've got year being treated as a factor. We could see this because we've got our two box plots. If we put year as a factor in the ANOVA, then we're comparing the years to one another. If significant, if it comes out in our ANOVA that it looks like the year accounts for a large portion of variability in yield when it's treated as a factor, then that implies that at least 1 year has a different kind of average yield to at least another year. We can also have year as a numerical variable in our bottom plot, where it's less clear here because we only have 2 years that we're looking at, but we've got our kind of 1970 and our 1971, and we're testing to see if, or we're looking in the ANOVA to see if this is a flat horizontal line. If here we are confident that if in the ANOVA, when year is treated as a numerical variable, it shows that year accounts for a large portion of variability, then that tells us that there's a trend between the year and outcome variable. It's up to you and the question on whether you want to treat something as a factor or as a continuous variable. And we have a little bit more on this back in topic 5. So overall, we can compare what our ANOVA says about variables that impact variability to what our visualizations show. The visualizations and ANOVA should be telling you the same thing. The visualizations are there to help you interpret your results and reach the correct conclusion. For example, the correct conclusion with protein and oil is that protein and oil account for the same variability, more or less, in yield, rather than that protein doesn't account for any variability. This is not clear from viewing just the ANOVA. Thank you.